Welcome to another edition of RCE. Again, this is Brock Palin. You can find us online at rce-cast.com, where you can find links to our Twitters, our blogs, all that fun stuff. Once again, I have Jeff Squires from Cisco Systems and one of the authors of OpenMPI. Jeff, thanks again for your time.
Hey, Brock, how are you? It's getting to be fall here, which means it's getting to be the ramp-up time for supercomputing.
Right. So, once again, I believe we both have booths this year.
Yeah.
I am not directly participating in anything, but a number of us will be participating in panels on ARM for scientific computing, machine learning, GPU computing, a number of other different, little things that we've dabbled in over the last couple of years. So this is probably the most involved year we've ever been with supercomputing for my group.
Yeah, that spans a wide gambit there, and I'll be having the usual OpenMPI Birds of a Feather session with Dr. George Basilica from the University of Tennessee, given the state of the union of where we are in OpenMPI and where it's going and all these things. So love to see all of you there. But enough about supercomputing. Let's talk about today, Brock. Who do we have?
Okay, so our topic today, we have Dr. Bryan Granger to talk to us about Jupyter. So, Bryan, why don't you take a moment to introduce yourself?
Yeah, thanks so much for having me here today, Jeff and Brock. And I'm a professor of physics at Cal Poly State University in San Luis Obispo. And my background is theoretical atomic physics, but for the last, decade or decade and a half, I've gotten very involved in open source software development, originally in the scientific computing space, sort of before data science was a thing. And then as the entire sort of universe has shifted around this new idea of data science, a lot of the open source projects I'm working on are sort of right in the middle of data science, but also continue to be relevant in traditional scientific computing as well. That includes Project Jupyter. I'm one of the leaders and core developers of Jupyter and IPython. And then also in the last year, I've been working with Jake Vanderplas on a new data visualization library called Altair.
So that's kind of funny because actually my degree is in nuclear engineering, got into scientific computing, started off with the classic, scientific computing. In the last couple of years, with the rise of data science, I'm doing a lot more data science infrastructure for people in social science, health, IoT, and engineering, and then everything else. So it's funny, kind of parallel tracks.
Yeah, I think there's a lot of us who've taken very parallel tracks in that respect.
This is amusing. I'm the odd man out on this podcast here, where I am the only pure computer engineer.
We just consume what you do.
Yes, apparently so.
Yeah.
Yes.
So, Bryan, can you give us a little bit of detail? We're here to talk about Jupyter. What is Jupyter?
Yeah, so Jupyter is a sort of offspring of IPython, and so I can start with a brief history of IPython. It started in 2001. Fernando Perez, a classmate of mine at the University of Colorado in graduate school, started IPython originally as an enhanced interactive shell for Python. This is sort of in the very early days of Python starting to be used in scientific computing, and Fernando had long been a user of Mathematica, as I was, and really missed a lot of the sort of niceties that Mathematica offers for working interactively with code. And so he started IPython in 2001 to bring that to Python. And for the first roughly decade, it remained a terminal-based interactive shell for Python. And then in 2001, we built a web-based notebook. It was part of IPython at the time. And over the following years, we abstracted out an architecture that allowed other languages to plug into that web-based notebook. And Jupyter was born as sort of the language-independent part of the overall effort. And so today, we refer to that notebook as the Jupyter Notebook. IPython continues to exist as one of the language extensions, or as we call it, a kernel for Jupyter, which provides basically the Python language support for Jupyter.
So where did the name Jupyter come from? And particularly, it's got a slightly odd spelling. There must be a story behind that.
Yeah, it was a long time for us sort of hunting and trying to find a name that met the basic constraints of something that was open on domain names, open on GitHub, Twitter, etc. And so that once you impose all of those constraints, there's not much left. We also wanted to name that sort of nodded in the direction of our scientific computing heritage. And so you've got Jupyter, Galileo sort of built into the name. And then also the fact that even though Jupyter is language independent and we support many different languages, our Python heritage as well. And so the sort of changing the I in the name Jupyter to a Y is where we ended up. At times, we've said the name also sort of has fragments of some of the main languages we support, namely Julia, Python, and R. So you could think of Jupyter. I think that's a little bit tongue-in-cheek, but if your listeners want to take that seriously, that's also completely fine. I think some people in our community, that's the folklore that's emerged around the name, and I'm completely fine with that.
So for those who haven't seen this before, why would you not just use a Python, Julia, or R IDE?
Yeah, that's a great question. And it's a question that is becoming more difficult for us to answer. And so let me first give the answer looking back. The main thing that the notebook, the Jupyter Notebook provides is interactive computing. So when someone is running a computation, and while it's still running, writing more code, submitting it, and looking at output. And so it's really optimized around that type of workflow. And that in combination with a more of a narrative format. So the Jupyter Notebook is actually a document that a user would create that mixes live code with narrative text, LaTeX equations, visualizations. And so at the end of it, not only have you sort of been able to do your interactive computing yourself, you end up with an artifact that can be used to reproduce the work, share the work with other people, etc. And so traditional IDEs don't offer those two aspects of sort of reproducible interactive computing and then what we refer to as a computational narrative that can be shared with other people.
This is the concept of literate programming, right? The idea that you can have all of your documentation and everything embedded, but it's more for learning rather than actual documentation.
Yeah, we like to use the word computational narrative rather than literate computing. The original vision of literate computing was slightly different in that it wasn't designed to be an interactive experience. It was more that you would have a single file that contained the source code and the documentation, and then later run various post-processing steps to generate documentation or source code. Whereas what we're talking about here is an actual live interactive computation in the middle of a document that honestly looks more like a Google Drive document or a Microsoft Word document than a traditional IDE.
So yeah, this actually kind of strikes me, and I'm going to date myself a little bit by making this reference, but when I was doing research for this interview and looking into what Jupyter is and how it works and whatnot, it kind of struck me that this seemed like a Google Wave for science, particularly with the timing back when you started this in 2001 or so, that, Google Wave was the predecessor of Google Docs and Google Sheets and things like that, where they kind of introduced a lot of this technology where you could even have multiple authors working in a single workspace at the same time, and everybody gets a simulcast of exactly what's happening all throughout and stuff like that. But you've taken that and run with it even further